Awesome. I'm super passionate about this subject. I think it's the most important subject is responsible and safe AI, because if you don't have responsible and safe AI, you have no business. This includes hallucination risks. So I'm super passionate and to talk about this topic. Just my background, I spent almost a decade working on safe and responsible AI, starting at Appen, Scale AI, Scientific, and now Innodata. We're the responsible AI safe AI partners for Google, Meta, Amazon, OpenAI, and these guys spend hundreds of millions, billions of dollars on safe and responsible AI, mostly in the form of evals, RLHF, red teaming, data collection, and so it's a very interesting topic. So I'm super excited to welcome my panelists that are world class in this space. So maybe you guys can just do a intro.
Sure. Bob Rapp. I'm a co-founder of the. Can you guys hear me well in the back room? Okay. Co-founder of the AI GovOps Foundation with Ken Johnston. We worked together for about 30 years in responsible, safe kind of stuff. We think things should be gooder. I also lead a team at General Motors deploying AI for about 120,000 people. I'd love to hear what you all think about how we ship good AI and we don't ship bad AI.
Hey, I'm Prashant. I am with Google Trust and Safety. I take care of the software engineering and technology teams for trust and safety, essentially.
Cool. Hi, I'm Ameya. I spent my career at the... How about now? All right. Hi, I'm Ameya, and I spent my career at the intersection of AI and security and safety. I led the smart screen team at Microsoft, where we built, at that time, the largest ML models in the world, protecting users from social engineered attacks like phishing, scams, and socially engineered malware. I spent time at Facebook building multimodal models so that we could do a better job at understanding complex content to deal with things like hate speech and horrible things like CSAM. And after that, I led AI at Dropbox. And more recently, I am a VP and field CTO at Braintrust, where we build the evals and observability platform. And I have the opportunity to work with some of the best AI teams in the world. We work with folks from Lovable, Notion, OpenAI, Rapp, Stripe, and I get to see how they are building and shipping AI responsibly into production. So a lot of my insights come from those conversations.
And congrats on that Monster Series B, I think led by A16Z, or I forget who. Iconic. We have a few iconic portfolio companies here. So just it's a very I love to define words, but if you can kind of define in terms of what safety or responsible AI means to you, and maybe just give some examples in your day-to-day work.
Well, and I do not speak on behalf of GM. These are my words. What I think safe and responsible AI is supposed to be is often what it isn't. So I would say that most safe and responsible things in big enterprises are meetings and PDFs and forms that you fill out, and sort of a lot of maybe gates. What actually happens is that people just do whatever they want and then later get in trouble. And I'll talk more about that. So.
Yeah, so I think for me, it's all about safety and trust ingrained in the entire stack of what you do, right from the time you are looking at a legal policy. How do you translate that into a product? How do you translate that into an engineering design and productionization of that? And even after production, how do you make sure that you are continuously upholding the bar on safety and trust? And that's why it has to be all throughout the life cycle of your product journey or process journey that needs to be kind of taken care of. So that's what we are trying to do all the time.
Yeah, when I think of responsible AI as really, the AI does what it is supposed to do, and it fails gracefully when it can't, right? I think that's sort of a fairly simple framework, but I think that's fairly comprehensive. And it's very underrated to sort of like say an AI does what it does, what is expected to do well. And so having the right mechanisms to ensure that you are testing your AI to operate within the constraints that you have specified, and you're able to do that with a high degree of confidence really is a big step forward to helping you ship something that you know is going to work well. And this is not just like, a particular dimension of, responsible AI. It's holistic. Responsible AI is part of the definition of how you want your AI to work in the real world. And, as long as you can ensure that it is working within those bounds, I think you're doing a good job shipping something that is going to be responsible.
Thank you. And I think 6 months ago, MIT had a study that 95% of AI are failing in pilots, and LMs are actually it's considered a black box. So it's a very, I can see why many of the pilots are failing. What are some of the from moving from pilot to production? What are the biggest challenges that teams need to solve to deploy these models responsibly in production?
Well, so people keep talking about the guardrails. I don't know what kind of driver you are. I'm not a very good one. By the time I've hit the guardrails, it's too late. So I notice that people talk a lot about policy, but they don't actually implement policy. If I think about FinOps, SecOps, all the other ops, we started with manual processes. We then automated them, and then we finally built some standards for contracts and those sorts of things. With AI, we don't have that. We don't have a common understanding of what good looks like, what is ready to ship, what is sufficient, how we deal with liability. There's a lot of opinions, and I get them every day. My favorite one is we're going to have LLM as judge. I'm like, excellent. So 3 people that don't know how to bake a cake are going to see if the cake is baked, right? But there are no global standards for what good looks like or sufficient or quality. So.
Enough. Switch. So I think one of the biggest barriers I've seen from proof of concept to productionization is mismatch in expectations. I've seen people trying to solve deterministic problems, which can be solved with a simple system, with a very complex probabilistic AI-based system, and then have the expectation that it's going to be 100% accurate because, it's a simple rule. Number of words in this line should be less than 100. So why can't AI do that? So I've seen naive assumptions that are not true. And on the other end of the spectrum, I've seen serious security kind of behaviors or not understanding security implications when you are doing AI productionization. I can give you an example. One of the team members, they were very excited, have built a system that can kind of take real-world understanding from internet and try to reason and optimize a process. But they didn't realize that like when you're making it internet calls, open internet calls, and you're using the same agent to access internal data as well as internet calls, you don't realize that there can be an attack. People can try to exfiltrate information by inserting a prompt that is not good. So having simple guardrails like, okay, when you have such use cases, have 2 systems. One that accesses internet is totally isolated from the one that is accessing internal data, a simple guardrail and protected by firewall. I think those are the things that if you take care of those well in the design phase, you will be protected. Otherwise, you have to bear the consequences of these decisions.
I think it's not surprising that most pilots fail, right? The typical pattern is you run a small pilot in your organization, you get really good signals, it looks green, everything's working well. You ship to production and then, it's chaotic, it doesn't work well. And, it's kind of understandable. A lot of these pilots are, operated with very well-defined use cases, and people have been trained to work with them a particular way. But by definition, production is adversarial, right? You're users are going to engage with your systems in ways that you had not anticipated, right? And so I think a big failure mode for a lot of these organizations, for a lot of these pilots, is that they don't really have a good understanding of what good looks like. They haven't defined what good looks like. And this is not a trivial task, because not only do you want to define what good looks like, you want to have the robust mechanisms in place to ensure that you are able to perform to that threshold, to that standard. And so being able to define exactly how your system should behave in a way that mirrors or reflects the real world interactions is going to be really critical for your pilots to actually make sense in production. And so I think the first step over there is you got to define what good is, you got to define your evals, and then you have to have confidence that what you're shipping is going to work well across your evals, and that your evals are actually, they're not just made up. A lot of folks can sit in a room, dream up evals, how my system should work, but the real data you're going to get is from when people actually kick the tires on your system. So the early days of your production deployments, instrument, gather a lot of data, go back and then tweak your system so that that actually works in production.
So, on that topic, I think, what are some of the best practices that you would advise people building agentic AI systems to be able to responsibly and safely deploy in production? Especially for me, the biggest pain I see is just hallucination. And if you can solve that, then the other safety and other things comes. But how do you solve hallucination in a LLM that's basically a black box? So maybe some tools, some thoughts around that for people building in agentic AI.
I mean, I think the way I think about like what are sort of the most important things that you need to nail before you ship something to production is, you want to make sure that you got observability. You're going to ship something in production. You want to know exactly how it performs. You want to know what went well and what didn't. And you're going to get a lot more signal from real world data than you can anticipating how the system could fail. You're going to be surprised in the variety of ways that your system is going to fail. And that is going to provide your developers with very objective, concrete information that they can use to very surgically go fix those kind of issues. So observability. Two is like define what's good and build evals, right? Like you just want to make sure that you have high confidence in the AI that you're shipping, that it is going to work as expected. Third thing is, as these agentic systems are becoming what I would call destructive in the sense that they can make changes on your behalf in other systems, you want to red team those. Like you really want to make sure that you have high degree of confidence that your systems are not going to do something catastrophic, even if that's like happening, 1% of the time. And then finally, like have someone be on point for owning the end-to-end performance and the quality of the AI. This is not something that's going to be a committee that's going to manage it. You need one DRI to own the system, be responsible for the quality, for the delivery, and give them agency to make sure that they're able to ship effectively into production. And so that would be my approach to how we go about shipping robust AI systems.
Great, thank you.
Yeah, probably +1 to everything here, and add on top of that guardrails in terms of you don't want agents to we want agents to be autonomous, but they have to be within a bounds of what is safe. So if you give agents access to database and access to drop operations or delete operations on database, agents can do cause serious damage.
Yeah, like that Replit example that deleted the whole database.
Yeah,
Or
and then it's irreversible damage sometimes, right? So you never do that. You have make sure you have identity for every agent. Every action that is taken by either a human or an agent or automate system, you have provenance and like reasoning why we took that action, so that you can go back in time. We talked about red teaming. I think that red teaming has been a way for us to ensure safety, but I think what we need is a continuous observability, which is like we associate observability with like SaaS and operational excellence and DevOps, but I think we need a similar rigor for agentic systems as well, where we are continuously not just looking at operational reliability, but also safety and updating our evals, continuously keeping a track on what are the users doing, plus one to what we just heard here. And that's so critical to think of it as a serious business with the continuous way of measuring how you are kind of performing on these aspects.
And the observability that you both mentioned, that's to be able to be explainable, right? The key is like you want to understand why this black box did what it did. Is that?
I think there's beyond that, right? So like models with simple models, we had to be able to detect shift in behavior of the model or training data. With agents, we have to be able to detect how agents are kind of thinking about changing their strategy, right? So we have to observe that shift as well. And sometimes with real data, in real world, and you don't change anything, you can see that agents are also there's a shift in the behavior of the agent over time. So how do you detect that? That's also critical to observe because they can start somebody can inject a prompt that can cause an agent to do harmful things. But how do you detect that, basically, right?
I think, yeah. So plus one. And by the way, really cool company. Love evaluating before you get fired, as I like to say. I think, Ken, one is immutable logging. So I want to know what the input, what the output, what the model, who did it, when, why, where. The second is, and Ken and I proposed 3 laws. I'd love to get community feedback. Number one, AI should not diminish human agency, dignity, or capacity, or erode the ability or gradually disempower humans, right? The second is AI systems will operate transparently within boundaries set by human governments at a speed by which humans can handle it. This is a really important thing about agents and agent swarms. Certain domains of human experience, creativity, democracy, raising children, expression of the soul, shall remain human only. And it's a really hard concept to say, because people say, what does good look like? We're talking to lots of software engineering people. I don't know if you've noticed, but 10 billion people are using AI, and there's some impacts that are really extraordinary that we can't see. And so if you can hire an agent, can you promote an agent? Can you fire an agent? How do you know? This is not about reading logs anymore. This isn't Grafana and Datadog. This is about real-time interactions that are really, really good ways to find a virus with a credit card or lose your gig, right? So.
Well, I can talk about observability for hours, but what I'll say is the way you're doing observability with agents now is you're not looking at like their performance characteristics. You're not looking at how long it took. What you're looking at, like, how did the system orchestrate the various tasks, right? What tools were called? Did the tools actually give you the right answers? Were the intermediate steps relevant? Were they adding meaningful value? Because what we are seeing is like these models are getting really good. So even if your agent is not great quality, many a times you're going to get the right answer eventually, right? But you still have a systemic issue. You still don't have a high degree of confidence that something might not go catastrophically wrong in some cases. And so being able to sort of trace these conversations. And so like you look at your agentic traces, they're going to be multi-turn. They are going to have multiple tool calls. There are going to be cases where a supervisor agent is calling another supervisor agent. And so being able to really understand how your agent is behaving at a step-by-step level becomes really important if you want to have very high confidence in your agent's ability to orchestrate tasks reliably to fulfill the user intent. And so the challenge is, without this, you may actually build a system that kind of sort of looks like it's working well, and it'll work well, like, a significant portion of the time. But when it fails, it can be a dramatically catastrophic failure. So.
So can you share an example where an AI system that you've deployed in production, it was harmful or the output was unexpected or hallucinated, and then how did you go about solving or resolving that
problem?
I mean,
Well, I could, but I'm pretty sure that my employer would be grumpy about that.
Just be anonymous saying a use case.
So a very good friend at a large drug company, she leads the AI team there, and I talk to peers all the time. There was a injection, essentially asking an agent to be more helpful, that allowed the drug to be sold, which sells for about $1,000 to $2,000 a month, to be sold for a negative number, so about $500 in rebate, and they lost many hundreds of thousands of dollars in the transaction. And that's the sort of thing we never talk about publicly because we would like to not have people know that we screwed up. But your point is, imagine things that look like they're working and we don't know if they're working because we're still learning how agents work, and it's terrifying. I've got agents deployed all over that I think I'm observing. I mean, I'm pretty sure I woke up competent, but I might be incompetent right now. So,
yeah, I'm trying to find a non-confidential example, right? So I think I'll just give a general, like, it's not about agent not working. It's about human behavior when we get too used to agent-based systems. And a hypothetical situation here is that we have a workflow that was largely manual. Now we introduced agents to try to automate parts of that workflow. And we see good results. And then we automate other parts of the workflow. So it's now 80, 90% automated. Now you get so used to that agent insights that you start to blindly trust it. And you forget that it's a probabilistic system. It's not a deterministic system. And you are, as a human, you are supposed to use your judgment still, but you start blindly trusting the agent, basically, because it's a psychology, right? So 9 out of 10 times it works. In healthcare, for instance, if it works 1 out of 10 times, it does a bad diagnosis. We have agent, right? A lot of automation. It's going to be a side effect of humans relying on them more and more, and then without realizing that they are dealing with a system that is not deterministic by design. So that can cause failures that are unexpected.
I've got a fun one. We at Dropbox we're building an enterprise search system called Dash. Now this system connects to all your apps: Slack, email, your Google Drive, your Salesforce, and it's a single pane of glass for performing searches. But not only that, you can also get summaries for your documents. So you can take multiple documents and synthesize a new document, a new proposal, a new spec, etc. And this is something, that worked well. We had evals to ensure that it was doing what it's supposed to do well. And we started going international. We got some customers in New Zealand, in Australia. And one of the escalations that we got was our customers in Australia were finding that the system was being fairly rude, using very colorful language, because it was synthesizing a lot of the information from Slack threads, and their Slack threads were very colorful. And so we had to sort of now think about that use case where we had to sort of instruct the agents and the things that were reasoning on the content to say you have to be very, very polite and not use expletives and slurs and stuff like that. So it was kind of funny, but it did cause an incident at their end because they were using this blindly to respond to emails. And they sent a few colorful emails that became pretty controversial for them. So, it was funny, but a lot of people were very annoyed, very unhappy with how that worked out.
insufficient. I mean, I've been reading all these news about rogue AI, right? In terms of even Clawbot spamming people and doing some malicious stuff. But so looking ahead in 2026, 27, with evolving regulations and technologies like agentic AI, I think it's like in the first inning of this early game that we're playing. It's pretty it's still very nascent. In terms of responsible practices in production, what skills will teams need the most moving forward in 2026, 2027?
I can go. I mean, I think, first of all, it's like really hard for me to predict anything more than 3 weeks out now. I think things are changing so much. Who knows what's going to happen in April or May. But I do think there are certain things that are going to be pretty important. These are enduring principles that I think will continue to shape how we build these kind of systems. One is the ability to articulate what your systems are supposed to do in effective ways. Because if you think about it, a lot of the work that we do in traditional software development is getting automated, right? Like a lot of the code is going to be vibe coded, it's going to be generated, but it's really going to be the judgment of the orchestrator, the person who's sort of like building this system. That's going to be important, but that judgment has to be translatable to the AI. And so the way you're going to do that is by being very crisp in terms of articulating how your systems should behave. So I do think that like evals and how you do system definitions is going to be a really important way to continue building these things. I think the other thing is also, how do you build the human processes to augment these automated systems that you build? Because more and more software is becoming non-deterministic. I was having a conversation with Vaibhav earlier that the amount of deterministic software that's being written is still extremely sizable, but all of that deterministic software is ultimately being orchestrated in agents. And so, like, how do you build the ability to inject human workflow into your systems and build out those processes? I think is going to be very relevant for the foreseeable future.
I think it's hard to predict beyond 2026, even 2026. The skills, like I've seen when we are writing software, right? So if you're dealing with legacy systems, I've not seen a huge success with the new coding tools, essentially. But when we are building brand new products, that is where we are seeing a lot of success of from Claude and Windsor and all these kind of new coding solutions. I think what the skills that I personally look for when I'm building a team is how good are you in using the tools that we have today, and what is your judgment on how good is your judgment on when to rely on a tool versus when to rely on your own systems engineering kind of skills, because you can generate the code, but I've not seen it generate that really nice system architecture that can sustain over a long period of time. So being able to use the judgment, being aware of what is happening in the industry now, and being smart about what to use when is probably the most important skill right now.
Well, first I want to thank you, Ken, for moderating the panel, and I want to +1 on a couple of things. One is this is really hard for humans. So the question of how humans can manage agents when agents never sleep, and we've seen Clawbot, right? The question of discernment and quality and integrity and those things. I hear a lot more discussions about good decision making. We chose to do a nonprofit foundation because we think the community needs to define what good looks like. It's up to the community. It's a global problem. What should humans do? What should Silicon do? What should the partnership be? And how do we know? And this is not primarily a technical problem, but the problem now is most policy is stuck in PDF and meetings and compliance and legal and other places. And the people actually shipping software or doing things with AI, it's kind of a cops and robbers things. We as developers are robbers. We just want to go do our thing. The cops would love to figure out what to do with us, but they don't really know. So they tell us what to do, and we ignore it mostly in most companies. AI in sales, marketing, customer-facing stuff. It was initially proposed as like 100 people. So we have 7. And every one of them is essentially a vice president level person, because we want a master person or man or woman who really knows what they're doing. Because if you really know what you're doing with AI, you can do really amazing things. If you really don't know what you're doing, you can do terrible things. The problem is the speed at which we can use tools inside the firewall is sort of maybe 1x, 2x. And then we go home and I'm using tools. I don't know if you used, Anthropic's computer, but if you think about what you can do, it's 1,000 or 10,000 times faster outside the firewall. Not necessarily better, faster. So we lose a lot of our very senior talent to lots of other companies, and our junior talent doesn't have anybody to talk to. There's no mentorship, right?
I think there's a balance between speed and security. And as part of central platform teams and infrastructure teams, it's on us to figure out how we can enable anybody to move fast. One of the things that I personally care about is that, and I'm seeing that happening, is that people, regardless of their job families, are building agents, spinning up new agents, and they are continue to do that at a very large scale. It becomes like writing SQL queries, right? So and how do we make sure that we provide them the right tools, the right data, the reliability layer, so they don't have to worry about it? And then regardless of your job family, if you are able to spin up an agent to automate your workflow on your own, while a central platform can provide you the observability and all those things, audits and compliance and all of that. So that is a key enabler that we are seeing. And I think that's the way to go. Maybe democratize it. And if you can't do it for every part of the organization, pick a part of organization where it is more realistic and start with that and expand from there, essentially.
I mean, my observation is the digital natives and the AI natives, they are starting to really question some of the security postures that they have within their organization. Like if it's becoming a source of friction to getting AI and adopting AI, people are having very foundational, honest conversations about why do we have this security posture, right? Previously, everyone thought security policy was sacrosanct. There's lots of layers of bureaucracy and lots of red tape, good or bad, but it was an apparatus that you didn't question, you didn't tinker around with. But now that's what I see is if the security team wants to enforce a certain policy, it better have a really, really good reason, because the shift is to get AI in as quickly as possible. This is mostly AI natives, digital natives. Not quite seeing that in the enterprise yet.
I think we'll just take actually two questions quickly.
Hi, it's Ameya. Question for actually all of you, but more especially what you talked about number of people and PP level. So I'll share one observation that I have working with now few companies in order to get them to deploy AI, how to do it faster, how to address all these things. One thing that became pretty clear to me now, if you start using myself, one thing became clear that I am using now the way they end up approaching building the AI code and the agent more as a baseline to how strong they are in how they approach what they work and how they think. It's no more just interview. When I ask them to say, hey, build this as an example, it's no more about interviewing them to say, let me interview them, how good they know what they know. It's about, build this for me in the next 2 weeks. Use any tools you want. Come back and tell me. And it's no more about what they produce, but how they approached it. That is telling me more about people than anything else.
Yeah.
So at the end of it, what I'm finding out is that where we are heading with the responsibility as well as the other elements to talk about. It all comes down to people who are building AI, their mindset, and how they're truly thinking things through. Rather, it's not just about purely speed anymore. And so, going back to what you talked about, I believe that whether consciousness or not, I truly believe that the real risk is about people who do not think it through in terms of what they're building it, come and actually build it and just launch it because they're like, yeah, I need to be fast because it's an AI day, I cannot wait for things. That's going to screw up more than anything else. And so I'd love to actually get your thoughts on that as well.
Yeah, well, when creation is essentially free, at least viewed by the people using vibe coding tools, I have a video I've done called Vibe Rant, where you say what's all the best practices for software development since the 1940s. By the way, that's a challenging question. But here's the problem. People don't know what they're good at. Self-awareness is not given equally. So terrible software developers think they're good software developers. I, by the way, am a terrible software developer. I like to share that. Nobody lets me do that anymore because I'm not very good at it. But it looks like I know what I'm doing when I use Replit and Lovable and other things, right? So the problem is the appearance of good. You end up with this AI crappage. But many people, I mean, software development in enterprises is pretty terrible. All software is awful until it's mediocre, right? So how can you tell the difference? And then what you do with all the extra mediocre people that aren't using AI tools that are scared of it, right? You can't retire everybody early. Sorry, this is not a GM comment. This is a Bob Rapp comment. So.
I don't know anything.
Yeah, I had a quick question for, first of all, Ameya and Prashant. So as founders, there are a lot of founders in the room. What's a moat these days? How do you think about moat? And for you, how do you think about build versus buy?
What's the moat these days as for a founder, and how do you think about build versus buy? So 2 questions, and then we'll take a break after this.
I mean, my observation is like it's easy to build software that works really well for you, right? I think everyone can now build software for themselves. But if you want to build software for 10 million people, it's not easy. It's something that I think is still a very hard problem. You want to have something that generalizes really, really well across a very large breadth of usage patterns. 2 is infrastructure is still not easy. Like building something that's going to scale and how you build that natively into your stack is still, it requires a deep understanding of how you build, how you do system design. And then the third thing is like, the quality of the experience is going to matter, right? Everyone can build a baseline level of experience, but getting it to a point where it is like extremely intuitive, works really well, has the taste, that is still very, very differentiated, right? So there's still some ways to get some moat in your product, but just writing something up is now table stakes.
I think in one sense, it's building something that people can trust to be reliable, safe, and it gets the job done is still very hard. You can vibe code a product. The moment you have to scale it to millions of people and make it open, available in public with a lot of adversaries, right? How do you protect your product against that? And then how do you protect your product against other people who can very easily copy that? So you can copy a product, but copying the infrastructure, copying the scale, copying the business, and that becomes very that is still very hard. Building a business is still very hard. So
Well, and I'll give it. And by the way, I didn't know that Glenn was in the audience, although I do expect a free cup of coffee later. At GM, we spend $200 billion a year. I think we also earn $200 billion a year, right? And I think we keep some of that. We buy a lot of software and we build a lot of software, but we're not very good at building software. I don't think of the last thing that you got from GM and it was a truck or a car. That's what we sell. And our CEO says, how do we sell trucks or cars faster, better, cheaper, gooder, safer, all those things? So the problem is people in this room, I mean, Seattle is a pretty interesting community. We think software is kind of obvious. Software is really hard. And we were having a lot of challenges with how we were doing enterprise search and AI. And Glean came in, literally, it was about, I think we decided to deploy it to everybody a couple months ago. It's extraordinary because something that's really good, that is supported for a long time. So when we get sued, they get sued first, and all those things you forget about. That's what we care about. We actually really don't care about the cost of software. We care about the cost of support forever, because our typical vehicle stays in the field for 7 years. Some of our vehicles stay as long as 25 years. And when software goes in those thingies, that liability tail. The other thing is, mostly AI is a story of lawsuits at the moment, right? People suing each other over who owns what. That's not interesting to people that make trucks and cars, right? Software is important, but it's not how we make our money. We make our money by keeping our customers safe and happy for life. So.
Awesome. I think I see Matt winning in the hobby area. So the buy versus build. Maybe we can talk here. But thank you so much, everyone. Thank you for the panelists for all your insights. So thank you. And we're gonna have Matt McElwain join us shortly from Madrona. Thank you so much.